The development of a civilization is measured by the complexity of the pipeline network that is present in any civilization. In our country, we have about 13,000 kilometers of gas pipelines, and these gas pipelines are subjected to different types of corrosions, failures, which can even create disturbances in terms of loss of human life. The pipelines that we have developed here, the network of 8-inch pipelines, they typically simulate the gas pipeline networks that is laid on the country. Through this, we are trying to understand that what are the types of failures that can come in such pipelines. There can be failures because of the welding joint. There can be failures because of the pits from which corrosion may start on the pipe. There can be even metal losses at different points, and there can be different types of dents or even cracks that can appear inside the pipeline. All of these different types of failures that's happening in the system, a robot which is traveling from inside the pipeline should pick up these different types of failures, should identify what is the nature of failure and where exactly the failure has occurred. If such a system is available with the country, then that can safeguard the gas pipelines and that can ensure the safety of the gas transportation. There is a very high demand of gas supply and fuel supply through the pipeline networks. Overall global market is growing at the rate of 5.7%, and the total economic value of such a system is about $9.7 billion. Now this kind of a system inside the Asia Pacific region is increasing at an even faster rate. Currently there is no national solution available to the problem. There are certain international companies which offers pipe investigation gauges. We call it PIG. These PIGs are operated by the companies and only the report of the pipelines are available at a very high rate, something like $100 per kilometer. But if we want to have our own solution in the form of a robot, then that can save these huge pipeline maintenance cost, and we can control the safety and operation of the pipeline with the help of our own robotic system. This is the adaptive intelligent pipe health monitoring robot that we have designed to mitigate the challenge of pipe health monitoring. Now this robot, as I said, that this is an adaptive robot. That is why it is designed into 4 parts, so that whatever is the complex shape of the pipeline, it can easily break itself into that many number of segments and it can move through the complex pipeline network. The total robot is about 16 kg of weight and about 1.25 meter of length. Now what are the novelties in this particular system? First important point is that the gas reflector or the deflection system that we have at the back plate, that is very unique. All other pipe investigation gauges that are available today, that are run in the basis of blocked flow condition, which completely blocks the flow. This has 2 disadvantages. One is that it actually disturbs the fuel supply in the pipeline, which means on service condition it is difficult to run. And secondly, because of this blocking, there is always a continuous vibration on the pipeline that creates disturbances, and it may actually jeopardize the pipeline's health itself. So this system does not touch it, only the wheels touch the pipe, and hence this deflector works very well in terms of smooth drag force generation and running of the system. The second uniqueness is that the deflector can actually vary the drag force because it has the vents in it. These vents can control or bypass some of the gases so that the drag force can be controlled. The next innovation is in terms of the speed control system. This is a unique speed control system which is not available in any pipe investigation robot. This system is completely passive in nature. The system extracts the wheel kinetic energy, and whenever the system or the robot is moving at a very high speed, this kinetic energy actuates the hydraulic system, and the hydraulic system applies the brake that automatically governs the speed of the system. Once again, if the robot is moving at a lower speed, then the hydraulic brake is released and the robot moves at a slightly higher operating speed. Thus, we can always ensure that the robot is moving at a uniform speed so that the scanning of the pipe internal surface is done in a very uniform manner. The next innovation that has been done is in terms of the optical sensing system. There is an very innovative infrared based optical sensing system, and this is good because in general the pipe investigation gauges comes up with only magnetic sensing system. But if a pipeline is non-magnetic in nature, let's say it is made of some polymer or it is made of some plastic pipeline, then the magnetic sensing, flux sensing would not work. In such cases, this infrared sensing system works very well. So what it does is that it shines the infrared on the pipe surface, and then the reflected light is sensed back through a light detective resistor, LDR, and depending on the nature of cracks or the nature of anomalies on the pipe surface, this reflected signal varies, and hence that can be interpreted in terms of defects in the pipeline. The very next sensor is also very unique. This is a touch sensor. No other pipe investigation robot in the world has a touch sensor related to it. The applicability, the suitability of touch sensor is that the amount of data that it procures, the data density is much lower than a video sensing system, and hence it can record for miles the motion of the robot and the pipe condition. In fact, this entire robot is designed for 100-kilometer run at one shot. So this touch sensors essentially touches the pipe surface, and as it touches the pipe surface, the nature of vibration, just like a spider leg, actually determines that whether there are anomalies in the system or not. And then we have the magnetic flux sensor, where also we have a new innovation that instead of using any traditional Hall sensor, we have a giant magnetoresistance sensors or GMR sensor. So it is a highly sensitive sensing system which reduces the load on the magnet. We can run this system with a much lower magnetic flux intensity. The last very important point is that this is an intelligent robot, where from the source of intelligence comes out, and that is there at the central part, and that in that element we have the microprocessors, and they actually collect the data from all these sensors, and they continuously give through wireless signal the in-track motion, the live tracking motion of the robot as it moves inside the pipeline, which gets received through the transceivers to different systems like mobile networks or computers. And the microprocessor also records all the sensor data together, which is later on processed through our own GUI based software, and that software is enabled with a machine learning system so that we can find out that what is the nature of the anomaly, what is the exact location of the anomaly, and how critical is the anomaly. This is an unique system which does not exist under any current pipe investigation robotic system available in the world.
3, 2, 1.
There are 2 patents that has been obtained on this robot. One is the complete robotic system and the other is the speed control system. We are ready for installation of such robots, and any interested person can contact our team for this.